All right, everyone. Uh, Wonderful New Year to you all. We hope that this New Year is going to be a wonderful one for all of us all. And we know that very in a short while we will be taking our terminal exams. That is WAEC, NECO, JAMB, and the likes. So in this New Year, I'm going to be doing a series of videos on subjects, science-related subjects such as physics, mathematics, and chemistry. Physics and mathematics in particular for JAMB exams. So for this particular class, I'm going to be taking on JAMB 2021 past question. And the essence of this video is to show to us how we'll be able to, you know, get to accustom ourselves with these questions and how to answer the questions and how to do them even easily without needing to use calculators all the time. Because JAMB questions are usually structured in such a way that they can easily be answered without needing to use calculators. So without much ado, let us quickly start with the first question here, question number 1. So for question number 1, the question goes, the slope of the straight line displacement time graph indicates. Now, before I give you the answer to this, I want you to look at it. So here we have a displacement time graph. So you are plotting displacement against time. So what that simply means is that you are plotting displacement on the vertical axis and you have placed plotting time on the horizontal axis. Let me just use T for displacement and T for time. Now the slope is going to look like this. A straight line graph. It's going to be a straight line graph. Don't mind my diagram. This side is not always that straight because I don't have a ruler, but that is how it should look like. Now when you have a graph like this and you are asked to look for you're asked to explain what the slope means. It means that you just divide the component on the vertical axis by the component on the horizontal axis. What it means is that just divide the first component here or parameter here with the second parameter here. So for this, you can see that this is distance, or sorry, displacement divided by time. And in physics, when you divide displacement by time, you get velocity. So if it's a straight line graph like this, it means that the velocity is what? Uniform. So the correct answer here is uniform velocity. So you see what I've done, even if you don't understand what this means, as long as you are dividing this by this, you should, the first parameter here by the second parameter, that should be able to tell you that, oh, velocity is defined as distance divided by time, or distance displacement over time, while speed is distance over time. So you can see that assuming it was distance the same, then this should have been uniform speed. Okay, question number 2. A man will exert the greatest pressure when he, okay, before I answer this also, I'll have to look at the options again. Lies flat on his back. Okay, let me just explain this. A man will always exert a higher pressure when the surface area is smaller. Let's see. You know that pressure is equal to force divided by area. So what this means is that if you increase the area, because the pressure is inversely proportional to the area, if you increase the area, the pressure will decrease. So if you want the pressure to be very high, if you want the pressure to go up, you have to decrease the area. So a smaller surface area, that is, if the area is smaller, the pressure will increase. So from there you can see that here we are going to have the smallest surface area is when a man stands on the toes of one of his foot. If he lies flat on his back, the back is going to provide a large surface area, so the pressure is going to be small. If he lies on his belly, same also with the back, it's the same as the back, it's going to provide a large surface area. If he stands on both feet, the area is not going to be as large as in option A and B, but it's still going to be enough. That is why a man can stand erect on his both feet without swaying left or right. But if you stand on the toes of one foot, you see that you will be unbalanced because the pressure is what? much more what? Higher. So the correct option is option D. So let's go to the next question, question 2. Which of the unit of the following physical quantities are derived? Here, I am going to list the 7 fundamental quantities. Then any quantity that is not part of this fundamental quantity is a derived quantity. So here are the fundamental quantity: mass measured in kilogram, length measured in meter, time measured in second, thermodynamic temperature or simply temperature measured in Kelvin, electric current which is measured in ampere, the amount of substance measured in mole, and the luminous intensity measured in candela. So from here you can look at this and find out that the only physical quantity that is not derived is mass. Mass is not derived, so all others are derived. So therefore 1, 2, and 3 are derived quantities. So the correct option is option B. So let's quickly move on to the next question. Question 4. A ball of mass 0.5 kilogram moving at 10 meters per second collides with another ball of equal mass at rest. If the two balls move off together after the impact, calculate their common velocity. So since they move on together after impact, it means that the kind of collision is inelastic collision. So we use the principle of conservation of momentum for inelastic collision. We have M1 U1 plus M2 U2 is equal to M1 plus M2 times their common velocity V. Now yes, what I'm going to do is this. Here, since the second object was at rest, it means that the momentum of the second object is going to be 0. So this is just going to be 0. Now, the first ball is 0.5 kilogram and it was moving at 10 meters per second. So M1 U1 is going to be 0.5 times 10. That's going to give me 5. So since this is 0, I'll leave that, is equal to. So I'm going to have the two masses are equal. The two objects are equal in masses. So 0.5 for the first mass and for the other 0.5. So when I add 0.5 plus 0.5, that's going to give me 1. 1 times V is equal to V. Now can you see what I've just done here? Without writing all the steps down, I have to add all those, do my multiplication and addition just in my head before putting them down. So you see that I arrive at V very easily. So V is equal to 5.0 meters per second. So that is how JAMB questions are. JAMB questions, they are questions that you can easily do mathematical operations on, even without using a calculator. And I'll try as much as possible to solve most of the problems here without using calculator, so that you see how it's done. So let's quickly move to the next question. Question 5. The motion of a body is simple harmonic motion if they. So here, let me quickly define simple harmonic motion. So simple harmonic motion is the motion of a body whose acceleration is directed towards a fixed point and it is directly proportional to the displacement of the object or the body from that fixed point. The fixed point is known as the center of motion or equilibrium position. So from here, let's use the definition to look at the options. Acceleration is always directed towards a fixed point. That's true. Part of motion is a straight line. It can also be on the curve anyway. Okay. Acceleration is proportional to the square of the distance from a fixed point. The formula for acceleration is A of simple harmonic is A equals minus omega squared x. Now this, you can see that the omega squared is the angular speed, that is constant. The angular speed is constant. So you can see that if this is constant, you can see that A is proportional to what? X. X is the displacement from the fixed point. So it means that this is not correct. This is also not correct. The acceleration is constant. and directed towards a fixed point. The acceleration is not constant, it's proportional to the distance or the displacement from the fixed point. So the only correct option here is this, is option A. It is always directed towards a fixed point, yes, and it is directly proportional to the displacement for that fixed point. So this is also not what? Correct. So option A is the correct option. So let's move on to the next one. So for question C is, which of the following is not correct about the molecules of a substance in a gaseous state? They are in a constant random motion. That's true. Have different speed. Yes, if they are in different random motion, then the speed should be different. So that is also true. Have a temperature which is measured by the average kinetic energy. That's the definition of temperature. The temperature of a body, according to kinetic molecular theory, is that it is the measure of the average kinetic energy of the molecules of a body. So that is also correct. The collision between the gases is perfectly inelastic. The molecules of the collision between molecules is a perfect elastic collision. So this is wrong. So that gives us the correct option. So let's go to the next one, question 7. So question 7 is giving us a given mass of gas has a pressure of 800 Newton per meter square at a temperature of 47 degrees centigrade. If the temperature is reduced to 27 degrees with volume remaining constant, the new pressure is, so this is actually a Charles law. So we have P1 divided by T1 is equal to P2 over T2. So what we're going to do here, I'll just, instead of doing all the cross multiply, but I'll just take this up this way, leaving P2 here. So that means P2 is going to be equal to P1 T2 divided by T1. So here P1 is 80, so I'm going to have 80 times P2 is 27 degrees. So I'm going to add 27 to 270. I have to convert it to Kelvin. So that gives me 300 divided by, then my T1 is 47 degrees. 47 degrees plus 273 is going to give me 320 degrees. Now watch how I'm going to work this out. This 0 will cancel out this. 8 here is 1. 8 here is 4. 4 here 2. Sorry, 2 here 2. 2 here is 150. And 150 divided by 2 is equal to 75. So the correct option is option B. Now for question 8, 0.5 kilogram of water at 10 degrees centigrade is completely converted to ice at 0 degrees centigrade by extracting 88,000 joules of heat from it. If the specific heat capacity of water is 4,200 joules per kilogram per Kelvin, calculate the specific latent heat of fusion of ice. Now look at this, there's a temperature change by extracting 88,000 joules of heat from the water, and again after extracting some amount of heat from it, the remaining heat out of the 88,000 was used to convert the water to what? Ice at 0 degrees. So the heat extracted, Q, is equal to mc delta theta plus m L. So here I'm going to have my m is 0.5. I'm going to have 0.5. Now first of all, let me add the plus a, the heat 88,000 is equal to that times specific capacity of water is 4200 times the temperature change is 10 minus 0, that's 10, plus the mass is 0.5 times L. Now I'm going to, this is how I'm going to multiply this. This times this is simply 42000 times 0.5 means I'm dividing by 2. So when I divide by 2, this is going to give me 21,000. So you see that here I'm going to subtract this from this. So I have 88,000 minus 21,000. So that's going to give me 67000 is equal to, remember we have this here, 0.5 L. So the next thing I have to do is to divide by 0.5. Dividing by 0.5 means that I'm multiplying by 2. So I'm just multiplying this by 2. So I have 0, 0, 0, 14, carry 1. I have 12, 13. The result is given in kilojoules. So I divide by 1000. So that gives me what? 134 kilojoules. Question 9. Which of the following instruments may be used to measure relative humidity? The instrument used to measure relative humidity is the hygrometer. Okay, 10. A source of sound produces wave in air of wavelength 1.65 meters. If the speed of sound in air is 330 meters per second, the period of vibration in air is, okay, we know that V is equal to F lambda. Also, V is also equal to lambda divided by period T. Why? Because we know that F is 1 over what? T. So we can use either this or this. Here we are asked to look for the period T. So from here, just make the period of T is equal to lambda divided by V. So that's going to give us 1.65 divided by 330. So to divide this, you can use your calculator to divide this if you so wish to, or you can just divide it with the other method. So let me divide with the calculator. So I'm going to have 1.65 divided by 330. So that's going to be 0.05. So my result is option B. So let's move to the next question. A boy standing some distance from the foot of a tall cliff claps his hand and hears an echo 0.5 seconds later. If the speed of sound is 340 meters per second, how far is he from the cliff? So questions that involve echo, you have to do this. V equals 2x divided by t, where s is the distance moved, because it's going to move twice the distance. It's going to move forward, hit an obstacle, and return back. So here we have to look for how far x, that is the distance. So s is going to be equal to vt divided by 2. So x is going to be equal to 340 times 0.5 divided by 2. Now when you are multiplying by 0.5, you are actually dividing by 2. So this is going to give us 170 divided by 2, and that's going to give us 85 meters. 85 meters. So the correct option is option D. For question 12, which of the following is not a vector quantity? A vector quantity is a quantity that has both magnitude and direction, and from this only temperature has magnitude without direction. Momentum, force, and displacement are all examples of vector quantity. So let's move to the next question, question 13.